Augmented reality glasses are coming, and developers should be paying attention because this is a full wearable computer that we can program with TypeScript. These are the Snap specs, and we can use them to make games or assistants or any kind of augmented reality web app. To get started, we have to download their AR development platform, which is Lens Studio. And we can use this to make lenses for Snapchats, or in this case, we're going to make a spectacles app. And you basically build out the UI for your apps in this 3D space right here. So we can drag in objects. Let's see, I'm going to grab a text 3D label. And we can use all of these controls to kind of move it around and style it and see how it looks. Maybe I'll just change that to a smiley face. And actually, I'll just show you what this looks like if we put this on the lenses. So there's the smiley face in 3D space, but we can't really do anything with it. It's just an asset that exists there. And there's a whole bunch of things you can add in here. You can set up a whole AR environment in this space, but I want to focus on the code because we can also come down here and create a new TypeScript file for our project. I'll just call this module 1 for now. And these are the assets for the project, so we can use any of these in the project. And for the code, I'm actually gonna open the entire project in Cursor, because I'm gonna use this to edit the files. And actually, if I double click on this here, it's gonna open it up in Cursor. It's just a TypeScript class that extends base script component. And this will get initialized by the application. And when it wakes up, we could just print out, I don't know, hello from specs. I'm gonna head back over to Lens Studio because this module is the class, but if I drag this into our scene, it's gonna create an instance of that class and actually run the code. And because it's running this preview over here, we can already see that that ran and we get hello from specs. So this means we can start adding logic to our application using TypeScript. And I'm going to head over to the docs here because they have a bunch of code examples. This one's for hand tracking. And I'm just going to take this first example here and I'm going to go back over to Cursor and just paste this in. Because now this class, when it starts up, is going to start tracking the left and right hand and just look for a pinch gesture on either of the hand, and then we'll just print out that it actually pinched. So if I run this now on the specs, we can see the little smiley face. And if I do just some pinch gestures, nothing's going to happen. I still can't interact with the smiley face, but we can see in the logs right here that we are detecting those pinch gestures and even where the gesture is happening. So we could start interacting with things in the real world just using this code. So I think every time I pinch, we should just add a smiley face wherever that is. And we could change the styling of this smiley face and then reuse it in our code. But I am not great with 3D stuff. However, I do know how to choose a font. We have a monospace one. That's kind of cool. Okay. And then on my 3D text, I'm just going to make sure that font is selected, which makes it look kind of funky. Okay. And then I can drag this back into assets to make what they call a prefab, which means I can now reuse it in my code. So I'm actually going to delete this from the scene so it's not just always in my face. And then we'll head back over to the code. And in this class, we can say that we are going to depend on an input from Lens Studio. I'll just call this prefab, and it is going to be an object prefab. Perfect. Okay. So that now means that this can reference that 3D text thing that we just made. And in Lens Studio, I just have to tell it, use that 3D text that I made. So now we can access that 3D object in the code. So I think I'm just going to focus on right hand for now. And when we pinch down, and we're going to create a new instance of the label that was passed in, and we're just going to put it in the current scene object. So this will actually put it on the screen, but then we need to transform it. So we'll get the transform, and then we'll set its world position to be at the tip of my index finger when I pinch. And now every time I pinch, we get a smiley face that just now exists. That's so awesome. Smiley faces. But now that I've got a ton of smiley faces here, I think I need a way to remove them. So back in the code, what I'm going to do is create an array of labels. And then I just need a function. Maybe I'll call this new scene. And we'll just loop through all the labels and destroy them. So now we just need a way to trigger this so that we can start over. And we could use a hand gesture. Maybe I could use my left hand for this. But let's look at what else Snap has to offer, because there's a bunch of different modules that we can use. And the automatic speech recognition module is a pretty cool one. So I'm going to again scroll down to the code example, maybe the one at the end. And in Lens Studio, I'll make another TypeScript file. Let's call this ASR module. And then I'm just going to paste in the code that I took from their example. And then we can just drag this in and see how it works. And the ASR module should just listen to me talking, and then it should be printing out right there. We can see it, what I'm saying, and if I'm done talking. And I can still draw smiley faces while I do that. So I think it'd be cool if I tell the app that I want to start a new scene. So we're going to go back into the code, and this is the function that gets called every time it detects that I've said something. So I'm going to check if it is the final, which means that I've finished my sentence, finished whatever I'm saying. And all we're going to do is if the event args.text, let's make sure it's lowercase. If it includes the word new, I don't even care what you say, just if it includes the word new, we are going to create a new scene. And to do this, we're going to actually need to trigger the new scene function in module 1. So I am going to say that we are depending on that. So we're going to need another input here. And actually, I need to import that too. Import... what was this called? Example hand script now. Let's call this drawing component. Okay. So we're going to import that from module 1. The naming is bad. This whole thing is going to need refactoring after, but this will do. So we're going to depend on the drawing component, which is of type drawing component. And then what we can do, if we need a new scene, we are going to say, yep, this drawing component new scene. So we're going to trigger that from here. That also means we need to go back into Lens Studio and say that the ASR module gets that instance of module 1, the drawing scene. So if this worked, I should be able to draw a whole bunch of smiley faces. And then if I use the word new, it clears the scene. So that's good enough. I mean, it's a little janky, but it's good enough. So I could say something like new scene, and we get to start over. Back in the drawing component, I'm going to do a few updates now because I think we can make this a little more fun. So I'm going to add some variables for the ASCII characters, and we've got a few other variables that are going to let us draw to the screen. So basically, when I pinch down, I'm going to set is drawing to true, so we know we're going to draw some stuff. And as long as I'm pinched down, it's going to keep drawing. And then when we pinch up, we're going to say we're not drawing anymore. Then we're going to have this update event that gets triggered every frame of the application. So it's going to get triggered a lot. So if we are currently drawing, then we can create a character at the position of the right hand. So basically, every frame, if I'm doing this, it's just going to create a new letter wherever I am. But we'll also check that we're not too close to a previous letter. We'll just have a distance check there. And then I have this create character function that is going to create a new label. It's going to pick a random letter from that letter array and make it appear on the screen. So now we should have an ASCII drawing app if I run this again. So now, there we go. We get a bunch of letters. So we're basically drawing ASCII art. That's awesome. So now let's look at how we can do some web dev stuff with this. The specs have a bunch of built-in things that we can use, like getting the user's location. We can access the internet. They have built-in modules so that we can connect to LLM models. But they recently just added Snap Cloud, which is Supabase, but hosted by Snap. And basically every Lens app can have its own Supabase backend. That's a database, real-time storage, edge functions. So we're going to take a look at how to use this in our application. If we head back over to Lens Studio, I can open up the Supabase dashboard and log into my account here. This is a specific Snap Supabase account. And I'm going to open up my dashboard in the browser here, which is a standard Supabase dashboard, but powered by Snap. And we're going to create a new project for this. So I'll call this ASCII drawing, and we'll put this in US East 1. And I'll come back to this in a little bit. Maybe we can set up a database and some storage and stuff. But I'm going to head back over to Lens Studio, and I'm going to import the credentials for my Snap Cloud. And this should give me, a Supabase project, ASCII drawing, and it's given me my details. So that's all imported into my project. And if we go back over to the docs, I think there's a code snippet I can copy from the bottom here. So I'm going to copy this TypeScript code, make a new TypeScript file. Let's call this one Supabase. And I'm going to paste that code in here. And I need to actually add Supabase to this project. That's the Supabase client. And now I have Supabase.js in my Lens app. And this is just the boilerplate code. So it's creating a new Supabase client. And then it's going to sign in the user. And the way the auth works works in these apps is it will just sign me in with my Snapchat account. So everything I do, all the data I store, can be secured in a way that only I can access it with my Snapchat account. And I am going to add a print statement to make sure this actually worked. And let's JSON stringify the entire user. And back in Lens Studio, I'm just going to make sure that this is part of the project. And then we need to associate the Supabase project with that. So I'm just going to select the ASCII drawing Supabase project. And when I run this, it should log me in, and we should be able to see the logs come out here. And there it is. I am logged in. That's my user ID. So I am authenticated with SnapCloud. And I think real-time would be the most fun for this type of app. So let's start there. And we're going to look at the broadcast API. So we're going to broadcast every time I'm drawing something. And then we can pick that up in like a web browser or something and maybe display the characters on the screen. And I'm going to do this the easy way by broadcasting straight from the client. So I'm going to take that code, and in my Supabase class, I'm going to create a function. I don't know, let's just call this broadcast, and I'll paste that in. So the first thing we're going to need, this is this.client, is a channel. I'm actually going to create this when we set everything up. So we're going to create a new channel, and we'll just call this ASCII channel, and we'll save that as a property. So this.channel equals, I'll just make sure I have a property for real-time channel, and I'll make sure I'm subscribed to the channel. And then anytime we want to broadcast something, we can do it through this channel. So this will be a broadcast event over WebSockets, and for this, it's going to come from the drawing app. And every time we create a new character, we have this vector, so it's XYZ position, and the actual random character that we're drawing. So on the Supabase side of things, I'm going to accept a character and X, Y, and Z coordinates. And then the payload here is going to be exactly that. And I'll just say there's a new character. And then in my drawing component, I'll just make sure I have access to Supabase. I'm going to rename that to Supabase. And then we'll just hook that up in Lens Studio. This is the instance of Supabase. And now that should be broadcasting out every single time I draw a letter, but I have nothing to listen to it on the other side. And this could maybe be another specs app, but I'm actually going to make a web app that listens for these events so that we can view it in the browser. So I already have a web app created. There's no JavaScript in here. It's a little bit of CSS. And the first thing we can do is just install the Supabase.js client, and then I'm just going to create a client. And we need the URL and the key, which I can grab from Lens Studio. So if I select the Supabase project, there's my URL, there's my public token. So I'm just going to paste these right in here. And now I should have Supabase in the browser that's connected to my specs app. So then I'll kind of do the same thing. We're going to need the ASCII channel. And in my specs app, I called that ASCII channel. So it has to just match whatever was in the specs app. And then we're going to listen for the new character broadcast event. In here, we're going to say on broadcast event new character. We got a payload. Let's just console log that out for now, and we'll subscribe to the channel. So if I start this web app up and we go and visit this in the browser, and then I need to make sure I'm actually sending that. So when we create the new letter, let's broadcast the letter and the positions to anyone that's listening. So let's run this app again. And now as I start drawing, we can see those events coming into the browser. We can see every single new character with its X, Y, and Z position in the browser. So now we just need to display that in the web page. And if I knew Three.js, we could make a really nice 3D model of this, but instead, we're just going to display a bunch of divs. That took a little tweaking to get right, but really this is the interesting stuff. So we're creating a div, and for each div, we're going to put the character inside of it and then put it in the correct XY position. And since it's 2D, we'll adjust the font size based on the Z value. And then I've also added another new scene broadcast event. So if I say new, then we can just clear the entire page there. And that did mean that in my Spectacles app, every time I create a new scene, I'm going to broadcast that new scene, which is literally just sending a new scene event on that channel. But this should mean that if I start drawing now, we'll be able to see all of that show up on my screen. That was a bad drawing. This is so much fun. And you just get that real time straight into the browser. So it's just sending it, broadcasting it on that channel, and anything can listen. That was supposed to be Sam. New drawing. I love this. But every time I create a new drawing, it just deletes everything that was already there, which means that we should persist this to the database, to that Postgres Supabase database, so that if I create a new drawing, at least the old one is saved. We can maybe view this on the specs or in the web browser or whatever we want, but we have a database, so we might as well use it. So we're going to head back over to the SnapCloud dashboard and go to the table editor, because we're going to add some tables. So the first one I want is a drawing table, which really just needs an ID, and I'm going to add the user ID. And this will be auth.userID. So we're going to make sure a drawing is associated with a user and only they can write and access it. That is not null. And then we're going to add a foreign key to the authorized user. And then we'll make another table, positions, and this is going to be for each of the characters that gets drawn to the screen. So here we're going to need the character, which I'm just going to make text, the X position, which can be int, and then we're going to have Y and Z. They're all the same, and none of them can be null. And we'll also need a drawing ID, which is going to be a foreign key to the drawing. Drawing ID is drawings.id. Then we need to add RLS policy. So I'm going to start with the drawings, and I'll just use enable users to view their own data. Yeah, so only if you own the drawing, you can select it out of the database. And for insert, do a similar thing. So you can insert only if you are authenticated, and you can only insert for yourself. You can't insert for anyone else. And then for positions, we can do a similar thing. So they can select their own data. We don't have a user ID on positions. So instead, we're going to replace this. And this checks if the user owns the drawing that they're trying to insert a position for. So we can save that policy and then basically do the exact same thing for insert. So the user can only insert or select positions for a drawing that they actually own. So then back in Lens Studio, I'm going to open up the Supabase window again. And we can import the database types into the project, which means that if we go back to the code, we can now import type database from the database types, and we'll give that to the Supabase client. So now it knows which tables we actually have. And I'll also import the tables type here, because my idea is that we'll have a current drawing, which will be, of type drawing or null, and we can see that it has the right type here. And we're going to start out and it won't have a drawing. We wouldn't have created one yet in the database. And before we broadcast anything out, we'll check if there is no current drawing. Then let's create one with a basic Supabase insert statement and a select statement to get it out. That looks good. I'll just make this async. And this is actually going to give us an error or data. So if there's an error, I guess we'll just log it out. And otherwise, we are going to set the current drawing. So if we have a current drawing, and actually, maybe I'll move this to the bottom of the function. So first we'll broadcast it out. Then we'll create a drawing if it doesn't exist. And then we can add the position to the positions table. So I'll await this.client from positions. We're going to insert the drawing ID, the character, and the XYZ positions. And realistically, I could just insert these into the database and then have the database do the broadcast for me and do that over a private channel, make it more secure. But I'm just going to leave it the way it is for now in this app. And then obviously when we have a new scene, I am just going to set the current drawing to null. And if we test this out, these are not ints. The XYZs are actually floats. So now when I start drawing, it should create just one drawing. Perfect. And now we should see the positions. There we go. Okay, so every time I do any drawing, the position will get stored in the database. And we could use this data inside of the specs. We could let people see their drawings. We could use it in the web browser. But I think we should finish this off by using the rest of the features here. So we have storage. I'm going to make a new bucket called images, and then I'm going to create a new edge function. And what I want this function to do, I'm just going to paste in code that I've already written here. I'm going to allow the specs to make a post request with a drawing ID. And the edge function is going to grab every single position for that drawing, and then it's going to generate an SVG using some SVG generation code. And then we're going to take that SVG and store it in the images bucket. And this is still going to be 2D. It's not going to look as good as the augmented reality stuff, but I still think it'll be fun. So we can deploy that function with the default name Clever Worker. And then back in the specs app, we can make a new function, create image, where we'll do this for the current drawing. We can call the Clever Worker function. This will be a post request, and the body just needs to contain the current drawing ID. So in the cloud, we have this code. It's an edge function. We could set up any kind of server code here. And this is just being invoked by the specs from this create image function. And I think I'm going to have this triggered by a voice command again. So right now we have new for new scene. If it includes, I don't know, let's say generate, then we're going to call the Supabase create image function. For that, we need to bring in Supabase and import it. So saying the word generate will trigger that edge function, and hopefully we'll create an SVG and store it in our bucket. And I just need to make sure it has access to Supabase. And then let's run this. So let's make sure things are still working. Yeah, we're still getting that real time. Sick. So now if I say generate, and I'm going to head back over to the bucket, because what I'm really hoping to see is an SVG. Sick. It's not perfect, but I love it. And I don't know where this type of tech is going and what apps will be built or what even should be built, but it was a lot of fun programming an app with these.